the last model, we are going to learn the combined variation. So anything other than direct variation and inverse variation, they all called a combined variation. So let's look at an example. Loss of heat through a wall. The loss of heat through a wall varies jointly, okay, the keyword is jointly, with the area of the wall and the difference between the inside and outside temperatures, and varies inversely with the thickness of the wall. And also write an equation that relates this quantity. So now, first let's denote those variables. Okay, if we let L represent the loss of heat, okay, and then the area of the wall, we use A to represent, okay, this is L, this is A. The difference between inside-outside temperature, okay, we use, since it's temperature, we use T to represent, and then varies inversely with the thickness of the wall. Thickness, we use D to represent, okay. So now write the equation related to these quantities. The loss of heat, okay, based on the description, should equals, and an area of the wall, it doesn't say varies inversely, and the default is varies directly. So A should be on the numerator, okay, and then difference between the inside-outside temperature T doesn't indicate its inverse variation, so the default will be the direct, and then it will be on the numerator, and then it specifies, right, the thickness of the wall is varies inversely, so the thickness of the wall D should be on the denominator, and then add a combined variation coefficient K. That's how to write the equation that relates all those quantities. All right. So let's try another combined variation example. Force of the wind on a window. Force F, okay, use F to represent the force of the wind on a flat surface positioned at a right angle to the direction of the wind, varies jointly, okay, so that's the combined variation, varies jointly with the area A of the surface, and then the square of the speed, okay, be careful, this is the square of the speed, so here is a V square, okay, of the wind. So based on this description, we can write a model, okay, we can construct a model first. So F should equals, it varies with area A and the V square, right? And then we add a constant K. This is the combined variation coefficient. So first we write a formula, relate those quantities, okay? And then we need to solve for the coefficient K. So the problem must give us one instance, right? It says a wind of 30 miles per hour. So V equals 30 miles per hour. Blowing on the window measured by 4 feet by 5 feet. So the area of the window is 4 by 5, which is 20 square feet. Right? Has a force of 150 pounds, so F equals 150 pounds. So based on these three quantities, we can plug in to our model, solve for the K, right? So 150 equals K times A, which is 20, and then times 30 squared, right? V squared. So we can solve the K. K equals 150 divided by 20, and then divided by 30 squared, right? 20 times 30 squared, both on the denominator, which is 150 divided by 20 times 900. 150 can cancel with 900 and with 6, so that's 1 over 20 times 6. K equals 1 out of 120. So now we can update the formula. F should equals 1 over 120 times A times V squared. Okay, that's our formula. This is a combined variation model we constructed. Now the question asks us, what force does a wind of 50 miles per hour exert on the window measured 3 feet by 4 feet? So now given the speed of the wind is 50 miles per hour, and then the window, which is, we can calculate the area, right? 3 by 4 window, so that's 3 times 4 equals 12 square feet, right? And then we calculate the force, so we can plug in 1 over 120 times A, which is 12, times V squared, that's a 50 squared, right? So 12, 120, we can cancel, that's 10, so that's denominator is 10, numerator 50 squared, that's 2500. 2500 divided by 10, that's 250 pounds. So 250 pounds, this wind of 50 miles per hour exerted on the window measures 3 by 4 feet. So that's how we use the combined variation model to solve a problem. So first step, you need to write a formula describe the relationship between all the quantities. And the second, we use one of the instances to solve for the coefficient K. And then we got a formula, and then we can calculate the variable. Okay. I think that's 2.5.